Hi everyone, welcome to our presentation on how search engines work. We're Otterly Intelligent, a computer science student group from CSU Monterey Bay's Cohort 23. I'm Claudia.
I'm Justin.
And I'm Mariah. We're excited to walk you through a technology that all of us rely on every day but rarely stop to think about: search engines. The average person types a query into Google without realizing the millions of calculations and systems happening behind the scenes, starting long before they ever hit search. Our goal today is to give you a look into that process, from how search engines discover and understand web pages to how they determine what you see and in what order.
Everything begins with crawling. Imagine the internet as a giant living map. Search engines send out bots like Googlebot to explore it. Crawlers start by visiting a set of known URLs and follow links on those pages to discover new ones. They also check for updates for existing content. But what gets crawled and how often isn't random. Crawling is guided by algorithms that consider how fast a website responds, how often the site updates, whether it throws out server errors, how popular or authoritative the site is. Google also considers a site's crawl budget, the number of pages it will crawl within a given time frame. This is influenced by site speed and importance. It uses crawl delay settings from robots.txt or inferred from site response times to avoid overloading servers.
Websites can control crawler access by using a robots.txt file. The file lets the crawlers know which parts of the site to avoid. This way, websites can keep private folders, internal search results, and other sensitive information out of search engine results. Then there's the sitemap. The sitemap acts as a directory for your site. It lists all the important pages and helps search engines discover new and updated content. It's not required, but it makes it easier for search engines to find all your important pages, especially the ones that don't have many internal links or are hard to reach.
Now that we've covered how websites can guide crawling behavior, let's take a look at the internal workflow behind the scenes. That brings us to the crawling pipeline, a structured system that explains how search engines take a flood of URLs and turn them into organized indexed data. Seed URLs are where website crawlers start. Seed URLs are a set of initial websites that the crawler begins with. These are manually provided or generated by topics of interest. The output then feeds into the URL queue.
The URL queue is a scheduler that organizes the URLs the crawler will visit next. It prioritizes which URLs, ensures that the crawler respects the website's rate limits, and avoids repeat visits. URLs are then pulled from the queue and given to the fetcher. The fetcher retrieves the content of a web page. It sends HTTP requests to the site and receives data in HTML or other formats. The responses are given to the next stage of the process.
The web server response is the literal content of the website. It is received and is usually in raw HTML. The content will then be parsed for data and links. The parser then processes the raw HTML and extracts relevant content. Content includes data such as article text, product information, metadata, or structured data. The content all depends on the crawler's purpose. This purpose also finds hyperlinks throughout the page, where the crawler gives two simultaneous outputs. Output 1, extracted data, information that is retrieved from web pages and passed to the database or index for storage. Option 2, feedback loop. The new URLs that are discovered are added to the queue, which promotes further crawling. The system keeps growing, discovering more and more. The final result, structured data, is indexed, and the new URLs keep the system crawling. The cycle continues, providing a vast, organized repository of web data.
Once a page is selected for crawling, it's fed, meaning the raw content is downloaded. From there, the page is rendered. Google processes the HTML, CSS, and JavaScript to see what the page actually looks like. This includes running scripts and loading dynamic content, which is especially important for modern JavaScript-heavy websites. Not all content is immediately visible to the crawler. If it's rendered dynamically and delayed, it may not be indexed at all. That's why many developers use server-side rendering or tools like Puppeteer or Rendertron to ensure key content is accessible.
Once rendered, pages are passed into the indexing stage. This is where Google tries to understand what the page is about. It extracts key information from text, headers, metadata, and even embedded files like images and videos. HTML tags like title, meta description, and H1 are especially important here. They help Google determine the page's topic, structure, and relevance. Google will also try to correct HTML errors, fix structural issues, and normalize content to improve indexing accuracy.
It also looks at structured data. These are extra annotations in your code, like schema.org tags, that help define what's on the page. For example, you can label something as a recipe, an event, or a product with reviews. Structured data helps Google feature content in rich snippets, like star ratings or event calendars, directly on the search page. Google also supports an indexing API for developers who want to push updates or new content quickly. This is useful for time-sensitive pages like job listings or live event announcements. Indexing also involves duplicate detection. If Google sees multiple pages with similar content, it creates what's called a duplicate cluster and selects a canonical version, usually the one with better signals like backlinks, mobile friendliness, and page speed. Developers can use it to suggest which version should be indexed. Only that canonical version is added to the Google Index, which is essentially Google's library of searchable content.
So what happens when someone actually types something into the search bar? This is where query processing kicks in. Google systems don't just look for keyword matches anymore. They interpret what the user means. This is done using natural language processing and entity recognition. Let's say you searched for best Thai food near me open now. Google has to identify what you're looking for, such as a restaurant, understand the cuisine, know your current location, prioritize real-time business hours. It might also expand your query using synonyms or related content. So a search for auto mechanic might also include search results for car repair. Google uses advanced models like BERT and to understand queries in context. These transformer-based models enable semantic understanding rather than just keyword matching. In some cases, Google may use vector search to find contextually similar content.
Now comes the most critical piece, ranking. Google's index returns a massive list of potential matches for the query. Then, its ranking system kicks in to decide which results you actually see and in what order. There are hundreds of ranking factors, and while the exact formula isn't public, we know it includes relevance to the query, page content quality, backlink authority, mobile usability, site speed, HTTPS security, and core web vitals, things like visual stability and load time.
Google also adjusts results based on user context. Your location, device type, language, and search history all play a role in making your experience tailored to you. Don't believe me? Try searching weather. It should show you the forecast based on your location. Or, if you're searching on your smartphone, Google might prioritize results with mobile-friendly websites. Machine learning models such as RankBrain further refine results by interpreting complex queries and predicting which answers will be the most relevant. This personalized approach aims to deliver high-quality results that meet each user's unique needs. Google also uses human search quality raters to evaluate results using EEAT criteria: experience, expertise, authoritativeness, and trustworthiness. Their feedback helps improve ranking systems and ensures content quality aligns with user expectations.
Once results are ranked, Google formats them into what we see as the familiar search engine results page, or SERP. Each result includes the title link, often pulled from the title tag or the page's heading, a snippet pulled from either the meta description or content that matches your query, the URL or breadcrumbs to help show where the page lives within the site, and sometimes a date if the content has a clear published or updated time.
You might also see different types of results, like image packs, video carousels, people also ask boxes, and rich results with stars or pricing. These are all part of Google's evolving search experience. Gone are the days of just blue links. Today, SERPs blend different content types and offer a more dynamic, helpful experience.
Search may seem instant, but it's the result of constant behind-the-scenes effort. Google is always recrawling, re-indexing, and re-ranking content to keep results fresh. And with billions of pages across the web, it's a huge challenge to keep that information accessible, relevant, and fast.
For us as computer science students and future developers, it's important to understand how search engines work, not just to improve visibility, but to build better, more accessible, and high-quality websites. Whether you're designing user interfaces, writing backend systems, or analyzing data, the fundamentals of search affect nearly every corner of tech.
So the next time you Google something like how to fix a 404 error, remember that you're tapping into a massive system built on crawling, rendering, indexing, machine learning, and a deep understanding of both language and user behavior.
Thanks so much for listening. We're Otterly Intelligent from CSU MB, and we hope you learned something new today. If you have any questions or want to go deeper on anything we've covered, we'd love to connect.